Okay guys, we just ended Unit 2 with solving quadratics, learning the 4 different ways to approach them. And today we're going to start Unit 3, which talks about using more of them. Quadratics are the basis for a lot in math. It allows us to do more things in the cubic function, and what we can do here with quadratics, we can do later on with other functions. Granted, we won't get to those necessarily in this class, but it gives you the potential in the future. So, that being said, what we're going to do is we're going to talk about the 3 different terms that we have when dealing with quadratic functions. And again, we all know how awesomely great my handwriting is. So this first term is the quadratic term. It's the term in front that involves the x squared. So for example, my quadratic term is ax squared. Next we have the linear term. The linear term is anything with just an x by itself. So in this case, we have my linear term being bx. And lastly, we have the constant term. The constant is any value in a function that has no variables surrounded with it. So it'll be just a number. It'll either be plus or minus a number. And I'm going to fix that side all the way around the word. So in this case, it's plus c. You could have a minus 4 or plus 7 or whatever. So first things first, we have to determine if something's linear or quadratic. In order to do that, we have to simplify it. So in this first one, we're going to have to FOIL, which we have seen foiling before. With red, remember that's first, outside, inside. Helps to spell. Let me tell you, not been good at that today. And last. And we only need to do it on the first one because if you notice, the second problem just is basic distributing. So to FOIL, we're going to do the first terms at first. So 2x times x, which is 2x squared. Then the outside. So 2x minus 4, which is negative 8x. Then we're going to do the inside, which is 3 times x, which is 3x. And then 3 times negative 4, which is a negative 12. So again, we've seen these before, just refreshing our memory. We're going to go ahead and simplify the function now. So I only have one x squared term, so I'd leave him alone. I'm going to go ahead and combine these guys because they're the same. They're like terms. So I have negative 8 plus 3, which is negative 5. And it still says 1x. And then the minus 12 by itself. So there's number 1 simplified. Now I'm asked for the quadratic term. Well, quadratic terms are anything with the squareds. So my quadratic term is 2x squared. My linear term is the thing with the x, so it's negative 5x. And my constant is negative 12. We're used to seeing signs in front, and any sign that is in front of that number is just going to get pulled with it. That's how we know if that's negative or positive. Remember, minuses are negative, and addition signs are positive. Alright. We notice here we don't have any 2 sets being multiplied together, so we can just distribute. So I have 3x squared minus 6x, again distributing again, minus 3x squared plus 6. So I'm going to look for the like stuff to go ahead and combine them. Well, I have 3x squared minus 3x squared, so those cancel each other out. So I'm left with a negative 6x plus 6. So we're asked to identify a quadratic linear constant. Well, we don't have a quadratic. It cancels each other out. So in this case, it's none. My linear term is a negative 6x, and my constant is a positive 6. All right. I think these are the last two. Yes. I want you to try these two on your own. Come back, see how it's going. We're going to FOIL here. We're going to just distribute over here. Now, if you notice in the second term, or number 4, excuse me, there's no constant. So in this case, I have a none down here. So whenever you don't have a specific, just write none. Don't put 0. I mean, I guess technically it could be 0. Just write none. It'll make your life easier. Just trust me on that. All right, so what is a parabola? A parabola is a U-shaped graph. It points up or down, but never both. I guess I can make that a wee little bit bigger. The axis of symmetry is centered at, the axis of symmetry is a vertical line located at the x coordinate of the vertex. And the vertex is either a maximum or a minimum. So it means it's either the highest, well, maximum, if it's a max, yeah, my maximum is highest or lowest point. Okay, so when I have a basic parabola, that being said, there's nothing else going on. There's no linear term, there's no constant term, it's just the quadratic term. The axis of symmetry is going to be at the line. Oh, you cannot really see that. I'll switch colors, make it a little bit more brighter. The axis of symmetry is going to be centered at the line x is 0. And that's going to be that line. Your vertex will be at 0, 0. Which again, I'm going to try and pick another bright color so you can see it. Let's go with hot pink. How does that sound? And your U will open up. Open up. And these are just basic, sorry, I'll leave that there for a second. These are just basic sketches. So that's when you're positive, and that's what tells you you're opening up. Your quad term is positive. Again, nice U shape going on. This one would be a minimum because it's the smallest. When it opens up, you have a minimum. Okay. When you have a negative version, again, the only difference is that you're going to flip down. So you're going to still have your axis of symmetry. What? Your axis of symmetry is still going to be x is equal to 0. Your vertex is still going to be at 0, 0. You're going to open down when your quad term is negative. And you're going to have a maximum because that's going to be the highest maximum. That's going to be the highest y value you're going to reach. So, for example, if I continue drawing my parabola, he's going to open down, so there's no other y values that are there. Well, it's supposed to be if you draw it correctly. There's no other y values that'll be as high as that one. Yeah, that'll do. We do. So what we're going to do now is we're going to identify some pieces of a basic graph. My vertex, now it's already graphed for me. We're going to learn how to graph it in a little bit. My vertex is going to be the bottom or topmost point. So in this case, since I'm opening up, it's a minimum and it's at the bottom. And that's at the point 1. Yeah, it's kind of hard to see. If I go ahead and darken these a little bit better, you can see the points. You can see your points. There. I like to make it a little bit sharper so you can see what I'm talking about. We're going to go ahead and look at, there's my mouse, this point down here because it's the lowest point. So starting at 0, 0, I go right 1, so positive 1, and then 1, 2, 3, 4, 5 down. So my vertex is at 1, negative 5. My axis of symmetry is going to lie on that same line, and that's always going to be the x value of my vertex. So in this case, it's going to be 1. And the reason I like my axis of symmetry is because it flips over on itself. That's the whole point of it. If I were to, bear with me for a moment, cover half of this guy up, I could reflect him onto the other half, which is how I get him to look like that. So the axis of symmetry allows me to talk about half of the graph at a time because I know the other half will look like a mirrored version of it. In a little bit, we're going to go ahead and try and graph reflective points. So first, we're asked to locate where P prime is. P prime, in this case, is going to be at 1, 2. 1, 2, 3, 4. So we're at 2, negative 4. And Q prime is at 1, 2, 3, negative 1. Again, if you notice, Q is reflected from Q prime. Focusing now on the axis of symmetry, not my axis, not my axes in general, not my x or my y axis, but my axis of symmetry, Q is 1, 2 away from my axis of symmetry to the left. So my Q prime also has to be 2 away from the right. my p is 1 away, my p prime is also 1 away. And notice how there's the same distance up. So for example, q is at, in this case, -1 in my y's, and so is q prime. Now my range is talking about my y values. We learned way back in Math A that range is with what happens with our y's. And when we're talking about parabolas, we're going to use a specific point. Now, my question to you is this. Based on my graph, are my y's ever going to get smaller than this initial point? Well, I have a point over here at 5, -7. I don't really know if that's a point. But would I really have a point here that would fall on this graph? No, it doesn't make sense. There's no logical explanation as to why my perfect U shape would somehow magically end up over here. So because of that, when I deal with the range, again, it's my y's. When I'm opening up, so here's my parabola. It's not a very good parabola. Here's my parabola. I'm opening up. My y's are getting bigger because remember, as I go up on my axis, my y's are increasing. And it can be equal to that. And it's going to be the y value of my vertex. So in this case, -5. The reason being is all of my y's are going to be bigger than that initial point. All right, let's take a look at the next one. Finding my vertex. He's at 1, 2, -1. And again, we know the axis of symmetry is going to be wherever the x value of my vertex is. So it's going to be at the line x is 2. If P is this dot over here at 1, 0, P prime is going to be the reflected version on the axis. The axis. Sorry. So he's going to be over here at 3, 0. If Q is up here at 1, 2, 3, 4, 0, Zero, 4. I'm sorry, that didn't sound. I was like, that doesn't sound right. If Q is up here at 0, 4, Q prime is going to be over here at 4, 1, 2, 3, 4. So all I'm doing is saying that if Q is over here, Q prime has to be here. If P is over here, P prime has to be over here in that spot. Again, we're opening up. So my y's are going to get bigger, and they're going to be bigger than that -1. Again, this guy is always going to be equal to this. Yep, this is my last one. Okay. So, last guy of the night. My vertex is at 1, 2, 1, 2, 3, 4. My axis of symmetry is at x is 2. In this one, my P and my P prime are not, my P and my Q, are not marked. So we can make them whichever one we want. So say I let this one be P and I let this one be Q. Now they don't have to be on the same side. My axis flips both ways. It doesn't matter. So if I want P to be the first one, my P prime would have to be across from it, so that would be at 1, 2, 3, 1, 2, 3. And therefore my Q prime would be at 0, 0. Or, if I wanted to, say this was my P, and this is my P prime. Then my P prime would be at 1, 2, 3, 4, 0. And say this guy was my Q, so this is my Q prime. Then that would be at 3, 3. Does that make sense? There's 4 different combinations you could really have here depending on where you want to put your P and your Q. It doesn't matter which one. It just depends on whichever one you want to make it. However, the range is going to stay the same. In this case, though, my parabola is opening down. He's a frowny face. So he's not getting bigger, he's getting smaller. And he's always going to be smaller than 4. Alright, enjoy your homework.